As you continue your study of numbers, you're learning that there are many different ways to classify numbers. Well, one way to classify numbers is to examine particular characteristics of those numbers. Classifying numbers by characteristics helps us make generalizations about sets and numbers and can provide insights into the relationships among numbers. Well, one important characteristic about numbers is whether they are even or odd. So there are some questions that you may have in the back of your mind. Is the number 0 even or odd? Why is the sum of two even numbers an even number? Or perhaps why is the product of two even numbers an even number? You'll begin to see that classifying numbers by certain characteristics will help identify number patterns as well. So for example, the last digit in an odd number, it's either 1, 3, 5, 7, or 9, and it leads to generalizations about numbers. The more that you know about a set of numbers, the more powerful they are in making sense of numerical situations. Well, there are a number of ways to check whether a number is even or odd, but probably the most common is to basically just take a number of pieces designated by that number. So let's use 12, okay, and then just try and divide them into two equal groups. So here I have some people, all right, stick figures, really technically. So what I've done was I've tried to divide them into two equal groups. All right, so we have 12 stick figures, and if I divide them here, all right, that puts 6 people on the left and 6 people on the right. So that right there shows that I was able to divide them into two separate equal groups and there are no remainders, all right? So if there was a remainder, then that will tell us that the number's odd. So that's how we can tell, okay? All right, let's look at another example. So is 13 even or odd? Well, let's try and divide these into two equal groups. All right, so I've got 1, 2, 3, 4, 5, 6, 7 over here. 1, 2, 3, 4, 5, 6. Oh, I don't have enough to make two equal groups because I'm going to have one left over, okay? So if I did 6 and 6, I still have one left over. So I'm going to have a remainder of 1, all right? Well, that right there is how you know that the number 13 is odd because there's one extra counter left over, okay? So basically if I take 13 and I divide it by 2 because I want to do two equal groups, all right, that's going to be 6 plus a remainder of 1. All right, so that remainder again tells me that 13 is odd and I cannot make two equal groups, okay? Another way that some people like to express evenness is by thinking about dancing partners, okay? If you're going out dancing, right, you need somebody to dance with, all right, typically. So when you have an even number of people, everyone has a partner, right, and they can form pairs. So if you have 13 people, not everyone is going to have a partner. So right there, there's another way to tell that that is an odd 13 is an odd number because there isn't an even number, and not everyone's going to have a partner. All right, so let's look at one of our questions. Is 0 even or odd? All right, well, we can't make a counter a 0 counter, right? I can't create something out of nothing, all right? So I can't divide it into two equal groups because I have nothing to use to divide, right? Well, since we can't use equal groups, we have to have another method to check this to see if it's even or odd, all right? Well, let's think about it. If we take 0 and we divide that by 2, right? Well, that means our quotient's going to be 0, right? And there's not going to be a remainder because 0 divided by 2 is 0. It's just not, you can't do it. Well, you can represent 0 also as 2 times n, where the n, okay, our variable n is going to equal 0. Again, 2 times 0 is 0, all right? So there is no value for n, our variable that's going to stand in there. There's no value for n that's going to work to make 2 times n plus 1 equal to 0, all right? So 0 is going to be an even number because there is no remainder. When you divide 0 by 2, it's 0. When you divide anything, all right, 0 by anything, it's going to be 0, okay, with no remainder. So that right there, there's no remainder. That right there is going to tell you that 0 is considered to be an even number. All right, let's move on to our next question. Why is the sum of two even numbers an even number? All right. Well, if a number is even, it can be represented using partners. Remember how I was talking about dancing partners, right? Well, think of that analogy, all right? combining two numbers that are each separated into groups of 2 results in a third number, right? The sum. So that's also separated into groups of 2. All right. So looking at the example here, we have 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, right? So 6 plus 4, you're going to have 10. Here, each of those has a partner. So that right there is showing you that it's even. Okay, so the sum of two even numbers is going to be an even number. All right. So now let's look at the sum of two odd numbers. All right. Well, that's also going to be an even number, right? So think about it. An odd number has what we can call leftovers, right? So when you have an odd number of counters, so here we're going to use these squares again, okay? You have 3 over here, and you're adding 5, okay? Both of those are odd numbers. Well, here's the leftover here for 3, and here's your leftover for 5, all right? Well, when you add those together, those guys pair up, and it becomes an even number, all right? So that's why the sum of two odd numbers is going to be an even number, because you have these two leftovers that end up pairing together. Okay, so then why is the product of two even numbers an even number? All right, well, one way to interpret multiplication is as a grouping operation. So for example, 2 times 4 can be interpreted as two groups of 4, right? So there's two groups of 4 here. Since there's an even number in each group, right, 4 is an even number, then the total amount is always going to be an even number, because see, they're always going to have a pair. There isn't any leftovers here. There's always, each of these has a pair. All right? So as you're learning, so when you generate lots of different examples, you're going to discover that the product of two odd numbers is an odd number. Well, why? In this case, think of multiplication as repeated addition. All right, 3 times 5 to illustrate. Here, okay, we have 3, 1, 2, 3 groups of 5. All right, and so we are basically multiplication. Okay, you're going to take those 3 groups of 5 and you're going to add them together. Okay, so you notice when you add them together, you've got an odd number, right? If you were adding just 2 groups of 5, okay, then it's going to be an even number. But you've got 3 groups, so there's always going to be a leftover that does not have a partner. All right? So again, so since every 2 odd numbers, when you add together, is going to be an even number, then the extra odd number that we have here is going to remain without a partner. All right? So again, it's going to then make it an odd number. Okay, I just wanted to go over one other important classification of numbers, all right? And this classification is actually going to be based on factors, all right? Well, a factor is a number that divides the number evenly and there is no remainder, okay? So, for example, the numbers 2, 3, 4, and 6 are factors of 24 because they divide into 24 evenly. There's no remainder. But 5 and 7 are not. If you try to divide 24 by 5, you're going to get a remainder, and the same with 7. Okay, so again, a factor of a number is going to divide evenly into that number with no remainder. Okay, so now that we understand what a factor is, the classification are prime and composite numbers. Okay, so with this classification, a prime number, it has exactly 2 unique factors, all right, one in itself. And a composite number, it has more than 2 factors. Okay, so this is another way to classify numbers as to whether it's going to be a prime number or a composite number. And one way to tell the difference is if it's prime, it's only going to have 2 factors, one in itself. Okay, so if it's not prime, it's going to be composite, which means it has more than 2 factors. Okay, another way to look at factors are the numbers that are multiplied to get a product are also called the factors of the product, all right? So let's look at our example. We used 24. Let's go ahead and use 24 again. So since 3 times 8 is 24, 3, 8, and 24 are called factors of 24. The other factors of 24 are 1, 2, 4, 6, and 12. So the set of all factors of 24 consists of 1, 2, 3, 4, 6, 8, 12, and 24. All right? Well, notice that when a number is divided by any of its factors, the remainder is 0. Remember how we had said that in our previous slide? So for this reason, the factors of a given number are also called divisors of the number. Okay, so you may also see that it's called a divisor of a number. And that concludes this video.